We are going to finish up with how this looks on our graphs. So there are a few things that are specific to trig functions, and those things are as follows. Does anyone know what we call that distance there?
Wave.
It does look a bit like a wave, by the way. Amplitude. I was waiting for it to pop back in. Now, that's an amplitude. We also have, and I liked Harrison's use of the word wave, because the next thing I'm going to talk about is the wavelength, which is also represented, well, it's got a different name in mathematics, but it means the same thing. We call that the period, which is simply the time it takes for one wave to occur. Cool? The period is simply the time it takes for one wave to occur. Now, what do you notice about the amplitude?
Same.
Is it? Yeah.
Supposed to be.
That's also the amplitude there. Is the amplitude our full distance between peak to trough?
No.
It's only half our distance, correct? And our wavelength is peak to peak. It could be trough to trough. Can it be midpoint to midpoint?
No.
You've got to go midpoint to the next midpoint at the same direction. Cool? So it's got to be doing the same thing at the same height for it to be a full wave. Happy with that? Good? Now, if I was to shift this vertically, often we just put a little thing like there. Let's say that's a 2, that's a 0. What's the amplitude of my function? What's the vertical shift? 2. Okay, we haven't talked about horizontal shift yet, but we will soon. That there in purple is a sine graph. So that is a sine. So if I was to write y equals, I'll write the actual function, 2 sine x plus 2, the wavelength being, let's call that 360. That is just that function there. Cool? Does that make sense?
Yeah.
Why is the wavelength 360?
Because
Think back to our unit circle. What happens at 360?
it's negative, it's a bulk.
Restarts again, doesn't it? There's a full circle, and then we restart the whole process again. Cool? If I was using radians, what would that become?
2 pi. 2 pi.
2 pi. You're right, got a question? No? So that could be 2 pi. Awesome. If I made this 2x, what would happen here? What would this become?
4.
4 pi?
Yeah. Oh,
Who has a different answer? So it was 2 pi before. So in the previous function, when x equals 2 pi, we had a complete circle, correct? Now I've got 2x, so I need the brackets to equal 2x, to equal 2 pi. 2x equals 2 pi.
oh.
It'd be the same.
Oh.
Might be the same. Half of what?
Oh, 2 pi.
Which is what? 1 pi, correct? So this becomes pi. So as we increase the number for b, does it stretch or does it push? Back in. Pushes back in, cool. What about as we increase the a value, does it stretch or push back in?
Straight.
Stretches, cool. So just have a lot to think about those things. Get ourselves out of trouble. So, can we please draw the following function? I'm going to draw an orange. Y equals negative 2 sine 2x plus 2.
First start.
So is the vertical shift different?
No.
Is the period different, or the horizontal dilation different?
No.
What's different?
Positive.
Give you 10 seconds to draw that. Just approximately what it would look like. Harry, what am I looking like? Where am I going first? Where do I start?
We're going to, no, it's supposed to be two.
So where do I start?
Two.
Here? Where am I going, up or down?
Down.
2? Where?
Yeah, down to 0.
Where do I hit 0?
In the middle of the
In the-
graph.
Between these two? Okay, like that.
Yes.
And where am I going?
Up.
And do I cross over this line, the purple one?
Yeah.
Where do I cross over?
2.
Very good.
So,
If you got that, well done.
yeah.
Cool. It's exactly the same, it's just been reflected.
You're right.
So we've now seen what a positive and a negative sine graph looks like. Positive sine graph goes up to start with, negative sine graph goes down to start with. Cool? What do you think the orange graph is?
So why is it 2 sine again? Why is it 2 sine? Yeah,
Because I kept the thing the same. It's a cosine function. Cool? What do you think this cosine rule is? Y equals.
any cosine.
So what's our A value? Sorry. What's our A value?
What do you want to be?
No, it's not whatever I want it to be.
3.
3. Is it going to be positive or negative? What do you reckon?
Positive.
How did you know that?
It's trough is second.
In our car circle, where is everything positive? So in the first quadrant, we would expect that if it's positive, we're going to get a positive value. Cool. So 3 cos. What's my? Have I got a stretch horizontally or not?
I can't tell.
How can't you tell?
There's only a 2 pi and a 0
Yeah, but where's the 2 pi curve?
at the end of the function.
At the end of a full wavelength, correct? So is there any dilation here? No. Is there any vertical shift? Where's it start?
3.
0? So there's been no, like it's not, I know it starts at 3, but where does it go? Where's the midpoint?
0.
0. Cool. So the midpoint's at 0, so we know that there's no vertical shift. Guess what I'm going to get you to sketch a function here. Which function am I going to get you to sketch? Negative 3 cos 2x. Hey, that old chestnut. I'll help you out by drawing where pi occurs. I'm such a nice guy.
When you say midpoint, do you mean like the middle of the peak?
The middle of the, between the, half between the peak and the trough.
Oh,
So here the trough occurs at 4. So the midpoint's 2.
oh, okay.
What's that?
Oh, yeah.
Alrighty. So is it going up or down to start with? Very good. Goes down. Oh, what have I done wrong? Very good. I've started in the wrong spot. It needs to start here, correct? And it needs to get to everyone happy with that? It's a wonky donkey, but you get the idea.
We're just trying to limit like pi and versus 2 pi and all that.
Pretty tricky, but very good. Sweet. So we're across vertical dilations, horizontal dilations, vertical shifts. We've talked about horizontal shifts. We haven't quite dealt with that to the level we need to yet, but we will get there. Any questions before we move on? No, very good. All right, back to our Atomy.